Okay, next we're going to use the associative, commutative, and identity properties to simplify, and I'm going to be real specific about why we're doing what we're doing so that we can use this seamlessly in the future. I know you've probably already taken negative 10x times negative 3 before, but I'm trying to explain why you're allowed to move things around. So when I have negative 10x times negative 3, what I'm allowed to do because of the commutative property, I am allowed to take the negative 3 and put it in front and multiply by the negative 10 x. And now because of the associative property of multiplication, I'm allowed to take the negative 3 times the negative 10, then times x. And then negative 3 times negative 10 is 30, 30x. And that is the simplified form. Now, most of you probably can do this, negative 10x times 3, multiply the coefficients to get negative 30x without any real work. But in this lesson, I'm just trying to explain to you why the associative, commutative, and identity properties are so helpful. The next one, I have 15a plus 2a minus 10. So I'm having the 2a minus 10 in parentheses first. So what I'm going to use is the associative property to rearrange the parentheses only. Notice that the terms all stay the same. I know there's a subtraction in it, but as long as the subtraction stays within the 10, you can still use these properties of addition. Now I can add the 15a plus 2a, and that's 17a. And that's our simplified answer because of the associative property. Now, eventually, later on this lesson, I'm not going to be explaining all this because you guys know that you're allowed to take 15a plus 2a, but the reason you're allowed to is because of the associative property. I'm going to use associative property again of multiplication here, and I'm going to change the parentheses to be around the 20 and 3 because I can't take 3 times x, but I can take 20 times 3, so I'm going to multiply that to get 60, 60x. 15 times 1 is 15. That one's just because of the identity property. X plus 0 is really just x. We don't ever really write plus 0. If the answer was x plus 0, we would write just x because the identity property of addition. And then here is another commutative property. I'm going to rearrange the 4 and put it in the front. Then I'm going to use the associative property and multiply the 4 times the 6 and get 24x. So that uses both commutative and associative. In the next section, we're using the distributive property. This is just a little bit of practice for the distributive property. The 4 in the front needs to distribute to both terms. So 4 times 2x is 8x. 4 times 9 is 36. Next, I have a negative 2 in front. That's going to distribute to both. Negative 2 times 5 is negative 10x. Negative 2 times 4 is negative 8. Distribute the 9. 9 times negative 2 is negative 18. 9 times 10x is 90x. And I'm totally okay with leaving it that way, although normally we prefer the 90 to be in front. We prefer the x to be in front, I'm sorry. So if I put the 90x in front, that means the 18 needs to go in the back. If I rearrange the order, make sure the negative is still with the 18. Now I'm going to accept either one of these today, but just in general, we like to have the x in front. This is a tricky one. A lot of times students have tricky with this. We have a negative out in front, or like if you want to put a negative 1 there, it's like a negative 1 distributing. And that's going to distribute to all 3 terms. A negative times a negative 2 is a positive 2x. Negative 1 times positive 9, that's negative 9y. Negative 1 times negative 7, that's a positive 7, which basically just changes all the signs. Okay, so those are our properties in action. So now we're going to use those. I'm not going to mention the properties every single time when we're simplifying. We're just going to remind you how to add and subtract some polynomials. 2 terms we say are like or similar terms if they have the same variable raised to the same exponent. So looking at the following 2, which ones are like terms? 3x and 9x. Looking at the x's, we have both of the variables the same. So these are what we call like terms. The next one, we have x squared and x cubed. 3x squared and 9x cubed. Now, the x squared and the x cubed have the same variable, but they are not raised to the same exponent, so therefore they are not like terms. The next one, 4x squared and 2x squared. The x squared and the x squared are the same, so we would call these like terms. 5x and 3y. The x and the y are not the same variable, therefore they are not like terms. And then the last one, 10xy squared and 4x squared y. They both have an x and a y, they both have a squared, but these are not like terms. And the reason they're not like terms is because the squared on the first one is on the y, so that means x times y. And on the second expression, we have x squared y, so that means x times y. So 2x's and 1y, and the other one's 1x and 2y. So these are not like. Now when you're adding or subtracting like terms, all you need to do is simply add the coefficients. The coefficients is just a really big word for the numbers in front of the variable. So add the coefficients and leave the common variable the same. Remember, they have to be like terms already, so they have to have a common variable. So just leave that variable the same. So 3x squared plus 9x squared, we add the 3 and the 9 and get 12, and the x squared stays the same. So this is just like you're combining things. So let's envision you have 3 x squareds on the table. So I have 3x squareds and you have 9x squareds. Let's put them together. What do we have? We have 12 x squareds. I don't change what they are when I'm adding. I'm just like counting how many I have. The next one's a little bit trickier. X squared y. Which one has an x squared y that's the same? Looks like the last one. 5x squared y minus 3x squared y. That gets us 2x squared y. Notice the x squared y doesn't change. The middle term, which was 7xy squared, is not the same, and it just has to stay there as a second term. I did add or subtract the following, but I can't add all three of them if they're not like terms, okay? So on the next one, x squared, that doesn't have any like terms, so that's just going to stay x squared. The minus 3x and minus 5x, those are like terms. I'm going to add their coefficients, negative 3 minus 8, and that's negative 8. Because they're the same signs, add the coefficients, keep their sign. And then the last one is plus 15, and he doesn't have any like terms either. So I have combined like terms for everything that I can. Next, when you're adding polynomials, this is very similar. Instead of just terms, you have a polynomial plus another polynomial. You're just going to combine like terms. Now, if you're subtracting polynomials, you first need to distribute the negative sign to the second parentheses, and then you're going to combine like terms. So I have some examples here of adding and subtracting. So the adding is on the left, so let's go ahead and do both of those on the left first, and then we'll come back and do the right. So I have a polynomial in the first parentheses plus another polynomial. So when I'm adding polynomials, I'm just looking for like terms. I see x squared as like 2x squared and 5x squared, and that adds to 7x squared. Next, I see a 3x and a minus 6x, and I just add those and get negative 3x. I subtract their values and take the larger sign because the signs are opposite. And then 4 is like terms with negative 3, so I add that and get 1. Let's do the one right below it because that's very similar. X cubed, 5x cubed. I don't see any other x cubes here, so that just stays the same. Next, I'm looking for x squareds. Yeah, I see another x squared here. So negative 2x squared plus 1x squared is negative 1x squared. And I look around for the next one. The next one I see, because I'm going down in order, I have x cubed and then I have x squared, so now I'm looking for x. 3x doesn't have any like terms, so you're just going to bring that down. And then numbers, plus 9 plus 7, I'm adding that to get plus 16. And that is as simplified as I can get. Now, remember when I said to subtract, you're going to distribute the negative sign to the second parentheses and then combine like terms. So I'm going to distribute here to the second parentheses. A negative times x squared is negative x squared. A negative times positive 3 is negative 3x. A negative times positive 7 is negative 7. The first parentheses doesn't get a negative in front, so it just comes down. At this point, I'm going to combine like terms. 5x squared minus x squared. Now, remember when you have an x squared, there is an invisible 1 in front. That is the multiplicative identity that tells you that there's a 1 in front, because 1 times anything is itself. So there must be an invisible coefficient of 1 there. So 5x squared minus 1x squared is 4x squared. Next I have plus x and minus 3x. Again, the multiplicative identity says that there's a 1 in front of that x. It's an invisible 1. So we have 1x minus 3x, that's negative 2x. And then I have plus 2 minus 7, which is minus 5, using my integer rules, and that is it. Okay, one more subtraction problem. Because there's a subtraction sign in between the two polynomials, I distribute my negative all the way through, which becomes plus 3x squared plus 2xy minus 4y squared. The first parenthesis stays the same. And now I'm looking for like terms. So I have 5x squared and 3x squared, and that adds to 8x squared. Let's see, xy and xy. I have two terms of xy. Negative xy, that's a negative 1. The multiplicative property tells me that if there's no coefficient, the coefficient must be a 1. So negative 1xy plus 2xy is 1xy. And then minus 6y minus 2y, that's negative 10, y squared, I should have said squared. None of these are like term x squared, xy, y squared, so those are as simplified as I can get.